Welcome. Take a moment to settle in. Find a comfortable place to rest, letting your body soften and your breathing slow. There's nothing you need to focus on, and nowhere you need to go. This is simply time set aside to be still, to listen, and to let the pace of the universe carry you gently forward. As this story unfolds, you're welcome to stay awake, to drift, or to fall asleep entirely. Everything will continue quietly, whether you're listening closely or resting deeply. Feel free to comment where you're tuning in from. When you're ready, let the light fade a little, and we'll begin. Chapter 1. Earth without the moon, the physical world. There are nights on Earth when the moon is hidden. It may be new or veiled behind cloud, or already set below the horizon. On those nights, the world feels slightly quieter. Shadows soften. The land rests under starlight alone. To imagine Earth without the moon, we can begin there. Not with catastrophe or loss or drama, but with darkness that feels steady and unchanging. A sky where no bright companion rises or falls, no silver arc to measure time. Only stars, distant and patient, scattered across a deep black sky. On this Earth, night arrives without ceremony. It does not wax or wane, it simply settles. The stars appear sharper here. Without moonlight washing over the sky, the Milky Way becomes more visible, stretching faintly from horizon to horizon. The planets shine more clearly. Constellations feel fixed, dependable, returning night after night without interruption. This is not an unfamiliar Earth. It is quieter, but still alive. The air moves as it always has. Winds still form where warm air rises and cool air sinks. Clouds gather, thin and dissolve. Rain still falls, one drop at a time. Oceans still breathe in slow, planetary rhythms. Yet something fundamental is missing. Not a presence we often think about during the day, but a force that has quietly shaped Earth since its earliest moments. To understand what changes when the moon is gone, it helps to step back, far back, into the early history of the planet itself. Earth formed more than 4 billion years ago, from a swirling disk of gas, dust, and rock surrounding the young sun. Over time, collisions brought material together. Gravity gathered fragments into larger bodies. Heat built. Differentiation followed. In our current understanding of Earth's history, the moon formed very early, after a massive collision between the young Earth and a Mars-sized body. The debris from that impact eventually coalesced into the moon, leaving Earth with a companion unusually large relative to its size. This explanation is well supported by geological evidence and computer modeling. It helps explain the moon's composition, orbit, and relationship with Earth. But in this imagined world, that collision never happened. Earth still forms. It still gathers mass. It still melts, cools, and settles into layers. But it does so alone. Without the moon, Earth retains more of its original angular momentum. It spins faster. In its earliest days, this faster rotation shortens the length of a day. Sunrises and sunsets come more quickly. The cycle of light and dark moves at a brisker pace. Over billions of years, the moon slowly acts as a brake on Earth's rotation, pulling energy away through tidal interactions. Without it, that slowing is far less pronounced. Days remain shorter for much longer stretches of geological time. This faster spin subtly reshapes the planet. The atmosphere responds first. Air currents are influenced by rotation, bending and twisting under the Coriolis effect. Faster rotation strengthens this influence, organizing winds into tighter bands. Weather patterns become more structured, flowing in long paths around the planet. The oceans respond as well. Without the moon, Tides still exist, but they are faint echoes of what we know today. The sun, distant but massive, continues to pull on Earth's oceans. Solar tides rise and fall, but they are weaker, gentler, and more uniform. Coastlines experience less daily change. The dramatic rhythm of high and low tide softens into something subtle, almost unnoticeable. Shorelines become quieter places. Intertidal zones, those narrow bands where land and sea trade places twice each day, are smaller and more stable. The constant exposure and submersion that shapes modern coastlines is reduced. Sediment settles differently. Nutrients move more slowly between land and sea. The ocean still moves, but with less pulse. Farther inland, rivers continue their patient work. They cut through rock grain by grain, carrying sediments toward the sea. Mountains rise and wear down as they always have, driven by forces deep within Earth's mantle. Plate tectonics does not stop. Heat still escapes from Earth's interior. Plates still drift. Continents still collide and separate over immense spans of time. Volcanoes still open brief windows into the planet's inner heat. But the moon's absence subtly changes how stable the planet feels over long ages. One of the moon's quietest roles is also one of its most important. It helps stabilize Earth's axial tilt. Earth does not spin straight up and down. Its axis is tilted, giving rise to seasons. Over time, gravitational interactions with other planets can cause that tilt to wobble. The moon acts as a steadying presence, dampening extreme shifts. Without it, Earth's tilt varies more widely. These changes do not happen quickly. They unfold over tens and hundreds of thousands of years. Seasons grow stronger or weaker. Climate belts drift north and south. Ice advances and retreats in different patterns. Still, Earth adapts. Ice forms where conditions allow. Forests spread where warmth and moisture linger. Deserts expand and contract. The planet remains dynamic, responsive, alive. What is lost is not stability, but predictability. And yet, even here, Earth remains a place of continuity. The sun still rises. The planet still turns. Time still moves forward, one quiet rotation after another. As the eons pass, Earth without the moon settles into its own rhythm. A rhythm shaped not by tides and lunar cycles, but by solar energy, internal heat, and the slow mathematics of gravity. It is a world not empty, but different, not broken, but reshaped. And it is on this quietly altered Earth that life will begin its long, patient journey. As Earth continues to turn without its lunar companion, the oceans slowly settle into patterns that feel simpler, but no less vast. In the absence of strong lunar tides, the surface of the sea appears calmer along much of the world's coastline. Water still rises and falls, guided by the sun and shaped by winds, storms, and the rotation of the planet itself. Yet the daily breathing of the shoreline becomes quieter, less pronounced. Wave action continues to sculpt beaches and cliffs. Storm surges still push seawater inland during powerful weather systems. But the regular, predictable exchange between land and sea softens. Over thousands of years, this changes how coastlines grow. Sediment carried by rivers reaches the ocean and settles more gradually. Deltas spread outward in slower, steadier forms. Estuaries become calmer environments, where fresh and salt water mix without the constant stirring of strong tides. These calmer margins between land and sea shape the chemistry of the oceans themselves. Nutrients still circulate, carried by currents driven by wind and differences in temperature and salinity. Warm water continues to rise near the equator and drift poleward. Cold, dense water sinks near the poles and slowly flows back toward lower latitudes along the seafloor. This great overturning circulation persists, powered by sunlight and Earth's rotation rather than by lunar pull. Without strong tides to mix shallow waters, some coastal regions develop stronger layers, with warm water resting above cooler depths. In other places, winds and storms provide the necessary energy to blend the water column. The ocean remains alive with motion, but its movements feel broader and slower, unfolding across seasons rather than hours. Above the sea, the atmosphere continues its own quiet work. Faster planetary rotation strengthens large-scale wind patterns. Jet streams become more tightly defined, flowing in smoother arcs around the globe. Trade winds remain steady, guiding surface currents across the oceans. Weather still changes from day to day, but the structure behind it feels more orderly. Storms form where warm, moist air rises and cooler air descends. Clouds gather, release rain, and dissolve. Thunder still rolls across warm continents. Snow still falls across high latitudes and mountain ranges. The absence of the moon does not still the sky. Instead, it shifts the balance of forces shaping it. Over longer spans of time, Earth's changing axial tilt begins to leave a deeper imprint on the planet's surface. As the tilt varies more widely, some eras experience stronger seasonal contrasts. Summers grow warmer at certain latitudes, winters colder. Ice sheets advance farther toward the equator during cooler intervals, then retreat again when conditions soften. These changes happen slowly, measured not in years, but in tens of thousands of years. Rivers adjust their courses. Forests migrate gradually across continents. Grasslands expand and contract. Deserts shift their boundaries. Earth remains resilient, continually finding new balances. Even without the moon's steadying presence, the planet does not tip into chaos. Instead, it explores a wider range of possibilities, testing different arrangements of climate and landscape. Through it all, time continues its quiet passage. Day follows night. Seasons pass into one another. Continents drift by distances too small to notice in a lifetime, yet vast when measured against deep time. From space, Earth still appears blue and white, wrapped in clouds, alive with motion. Only when watched closely, patiently, does its difference become clear. This is a planet shaped by solitude rather than companionship. A world guided by sunlight, gravity, and its own internal heat. And as the physical world settles into these patterns, it quietly prepares the stage for something else to emerge. In the calm waters of ancient seas, under darker nights and shorter days, the first simple forms of life will begin to take hold. Not all at once, not quickly, but slowly, as life always does. As millions of years pass, the surface of Earth continues to change, in ways that feel almost imperceptible, from one generation to the next. Continents drift across the planet, guided by the slow movement of tectonic plates beneath them. Ocean basins widen and narrow. Mountain ranges rise, only to be softened again by wind, rain, and ice. Without the moon's gravitational pull subtly stretching the planet, Earth's shape remains slightly more uniform. Tidal flexing of the crust is reduced, and the constant gentle deformation that accompanies strong tides fades into the background. The planet still flexes, but now mostly in response to forces from within. Deep beneath the surface, heat generated by radioactive decay continues to drive convection in the mantle. Hot material rises, cooler material sinks. Plates ride slowly atop these currents, reshaping the surface over spans of time, too large to grasp all at once. Volcanoes still form along plate boundaries and hotspots. Lava flows across the land, cools, and becomes rock. Ash settles, enriching soils over time. New land is added to continents grain by grain. Earth remains a world of renewal. In the absence of strong tides, coastal erosion proceeds more evenly. Cliffs retreat at measured rates. Beaches migrate slowly inland or outward, depending on wind patterns and sea level. Sea level itself continues to rise and fall, guided by climate rather than tides. During colder periods, vast amounts of water are locked away in ice sheets. During warmer intervals, meltwater returns to the oceans, lifting shorelines around the globe. These changes are broad and gradual, unfolding across thousands of years. The night sky above this earth remains dark and constant. Without the moon, nights do not brighten or dim. Darkness arrives each evening with the setting of the sun and remains until dawn. Animals that move beneath the stars adapt to this steady condition. The absence of moonlight subtly alters the distribution of energy at the surface. Nights cool slightly more quickly in some regions. Temperature contrasts between day and night grow sharper, especially in dry environments. Deserts, already shaped by extremes, feel this effect most strongly. Heat escapes rapidly after sunset, and cold settles in before morning. Life adjusts its rhythms accordingly. Across forests and grasslands, winds continue to move air and moisture. Leaves rustle, grasses bend. Seeds are carried from place to place, spreading life across the land. Rainfall patterns respond to the planet's faster rotation and shifting tilt. Some regions receive more consistent precipitation. Others experience longer dry intervals, punctuated by heavy storms. Rivers remain the planet's storytellers. They record these changes quietly, cutting new paths when conditions demand it, abandoning old channels when landscapes tilt or climate shifts. Over time, their sediments preserve a layered memory of the world above. Each layer tells of a different arrangement of temperature, vegetation, and water. Seen from far above, Earth still turns in silence. Clouds swirl across the oceans. Storm systems trace slow arcs. Ice glints faintly near the poles. Continents glow softly in reflected sunlight. The absence of the moon is not obvious at first glance. Only when time is allowed to stretch, when changes are measured in millennia rather than moments, does its influence become clear. This Earth is slightly faster, slightly darker, slightly less regular, yet it remains balanced. Gravity still binds it to the sun. The atmosphere still shields its surface. Water still moves freely between sky, land, and sea. The physical world settles into a long, quiet equilibrium. And within this equilibrium, conditions slowly emerge that allow chemistry to become something more. In shallow waters warmed by sunlight, molecules begin to gather. Energy flows through them. Reactions repeat, patterns form. And over vast stretches of time, those patterns will deepen, branch, and persist. But that story belongs to what comes next. For now, Earth without the moon continues its steady turning, unchanged from one night to the next, yet always moving forward. As time stretches onward, the interaction between Earth and the sun becomes even more central to the planet's unfolding story. Without the moon to share in shaping the night, sunlight becomes the primary external rhythm influencing the surface. Each sunrise brings warmth that spreads slowly across land and sea. Each sunset allows that warmth to fade back into space. This daily exchange of energy defines the boundaries of habitability. On continents, rocks absorb heat during the day and release it after dusk. Soils warm and cool in gentle cycles, influencing the movement of water through pores and channels beneath the surface. Plants respond not to moonlight, but to the length of day and the angle of the sun. In the oceans, sunlight penetrates the upper layers, warming surface waters and fueling slow-moving currents. Below, darkness remains constant, undisturbed by lunar glow. Temperature gradients form gradually, guiding vertical motion through the water column. The absence of strong tides allows thermal layering to persist longer in some regions. Warm surface waters linger above cooler depths, separated by gentle boundaries that shift with the seasons. Over time, this stratification influences how gases move between ocean and atmosphere. Oxygen produced near the surface dissolves and spreads slowly downward. Carbon dioxide released from deeper waters returns to the air at a measured pace. The exchange remains steady, shaped by winds and temperature rather than tidal stirring. The planet's faster rotation subtly reinforces this balance. Air masses circle the globe with greater coherence. Storm tracks follow more predictable paths, guided by latitude and season. While individual storms still vary, the broader patterns feel organized, almost deliberate. In higher latitudes, ice continues its quiet work. Snow falls during long winters and accumulates over time. Glaciers form where snowfall outpaces melting, flowing slowly downhill under their own weight. They carve valleys, transport rock, and leave behind layered records of past climates. Without the moon's stabilizing influence, shifts in axial tilt occasionally amplify these icy cycles. Some epochs see glaciers extend farther than before. Others bring long, gradual retreats. These transitions unfold over tens of thousands of years, allowing landscapes to respond without urgency. Rocks crack under freeze and thaw. Meltwater carries minerals downstream. Life, where it exists, adjusts its boundaries inch by inch. Across the equatorial regions, warmth remains more consistent. Sunlight arrives at high angles throughout the year, sustaining steady evaporation and rainfall. Tropical oceans absorb and redistribute heat, sending it poleward through slow currents and atmospheric flow. Rainforests, grasslands, and shallow seas find long-term stability here, even as the planet explores broader climatic ranges elsewhere. At night, the sky remains unchanged. Stars rise and set as Earth turns, but no bright disk interrupts their patterns. Constellations hold their shapes across generations. The Milky Way stretches faintly overhead, a constant presence rather than a rare spectacle. This unbroken darkness influences how the planet radiates heat back into space. Nights cool efficiently, especially in dry regions where clouds are few. Temperature differences between day and night become sharper, yet still manageable within the planet's atmospheric balance. Earth adjusts without resistance. Clouds form where moisture and temperature align. Winds redistribute heat. Water cycles endlessly between ocean, sky, and land. The physical world finds its rhythm not through oscillation, but through continuity. There is no monthly rise and fall written into the sea, no shifting light to mark passing weeks, only the steady turning of a planet bound to its star. In this constancy, the surface of Earth grows familiar with itself. Landscapes settle into forms shaped by long-term forces rather than frequent disturbance. Coastlines smooth, river deltas broaden, continental shelves extend gradually into the sea. Over immense spans of time, these quiet conditions allow complexity to gather. Chemical gradients persist. Stable environments endure long enough for reactions to repeat and refine themselves. The stage is prepared, not through sudden change, but through patience. And so, as Chapter 1 draws closer to its natural resting place, Earth without the moon stands revealed not as diminished, but as distinct. A planet guided by fewer rhythms, yet no less capable of sustaining motion, balance, and time. The physical world has settled. What follows will arise from within it. Even as the physical systems of Earth settle into long-lasting patterns, subtle variations continue to ripple through the planet's surface and skies. No world remains perfectly still. Small changes in solar output, Slight rearrangements of continents and slow shifts in ocean circulation introduce gentle variability. These changes do not disrupt the planet's balance, but they add texture to its long history. Along the edges of continents, shallow seas expand and contract as sea levels rise and fall over deep time. During warmer intervals, water spreads across continental shelves, creating broad, sunlit environments where sediments accumulate and chemistry unfolds in quiet repetition. During cooler periods, shorelines retreat, exposing new land to wind and rain. Rivers lengthen their courses, carving valleys deeper into rock. Each transition leaves a faint signature, layered into stone. Without the moon's tidal pull constantly reshaping the margins of the sea, these transitions feel smoother. Boundaries between land and water migrate slowly, guided more by climate than by daily motion. This gradualism shapes the character of the planet. Erosion becomes an unhurried conversation between rock, water, and air. Wind carries fine particles across plains and deserts. Rain dissolves minerals and transports them downslope. Ice grinds mountains into sand, then releases it again. The pace is consistent. The outcomes are enduring. Far below the surface, Earth's magnetic field continues to shield the planet from charged particles streaming outward from the sun. Generated by motion within the liquid outer core, this invisible barrier remains largely unaffected by the moon's absence. Auroras still glow near the poles during periods of heightened solar activity, painting slow arcs of light across dark skies. In the absence of moonlight, these displays appear sharper, more defined, though still fleeting. The magnetosphere hums quietly, another unseen system working without interruption. Above, the atmosphere maintains its layered structure. The lower troposphere carries weather and clouds. Higher layers thin gradually, merging into space. Without dramatic lunar forcing, the atmosphere's vertical motions rely more fully on solar heating and planetary rotation. Rising air cools and condenses. Descending air warms and dries. Over time, these processes reinforce familiar climate zones. Equatorial regions remain warm and moist. Subtropical belts favor aridity. Mid-latitudes experience shifting seasons, moderated by oceans and prevailing winds. Polar regions alternate between long accumulation of ice and slow release. The planet's faster rotation lends coherence to these zones, drawing them into broad, continuous bands that encircle the globe. At night, as the sun slips below the horizon, Earth radiates energy back into space. Heat stored during the day escapes upward, carried by infrared radiation. In the absence of lunar light, this process feels more complete, as darkness deepens and surface temperatures settle toward equilibrium. This nightly cooling reinforces the rhythm of days without adding complexity. One cycle follows another. The simplicity of these rhythms allows Earth's surface to remain remarkably stable across long spans of time. Landscapes endure, coastlines persist. Climate regimes shift slowly enough to allow adaptation rather than abrupt displacement. From a distant vantage point, the planet's motion appears almost meditative. Earth turns, clouds drift. Ice gleams faintly, and oceans absorb and release heat with quiet regularity. Nothing announces itself, nothing rushes. The absence of the moon does not leave a void. Instead, it leaves space for continuity. A planet guided by fewer external cues becomes more inwardly consistent, its systems shaped by long-term averages rather than frequent oscillation. As this chapter draws closer to its end, the physical world of Earth without the moon feels complete in itself. Its foundations are set, its rhythms are established, its future stretches forward, open and patient. In this environment, stable, enduring, and quietly dynamic, the next phase of the story will begin to unfold. Not suddenly, not dramatically, but in the only way Earth knows how: slowly. As Earth continues along this quiet path, one of the most enduring influences on its long-term behavior remains the slow geometry of its orbit around the Sun. Each year, Earth traces a gentle ellipse through space, held in place by gravity and momentum. The distance between Earth and the Sun changes slightly over the course of this journey, altering how much solar energy reaches the planet at different times. These variations are subtle, but over long spans of time, they contribute to gradual climate shifts. Without the Moon, these orbital influences become more prominent. The planet responds more directly to changes in its path and orientation, adjusting its climate in slow, measured ways. Over tens of thousands of years, small differences in seasonal sunlight accumulate. Summers grow marginally warmer or cooler at certain latitudes. Winters lengthen or shorten. Snowfall patterns adjust accordingly. When snow persists year after year, ice begins to grow. Glaciers form not through sudden cold, but through patience. Snow compacts into ice, layer by layer, preserving faint records of past atmospheres within tiny trapped bubbles. As ice thickens, it begins to flow outward, responding to gravity rather than urgency. Without strong lunar stabilization, Earth's axial tilt wanders through a broader range. At times, higher tilt angles bring warmer summers to polar regions, melting ice and redistributing water back into the oceans. At other times, lower tilt angles favor cooler summers, allowing ice to survive and expand. These cycles are long and unhurried. Ice advances slowly across continents, reshaping landscapes with quiet determination. Valleys deepen, plains flatten. Rock is ground into fine sediment, which is later carried away by meltwater. When climates shift again, ice retreats just as slowly, leaving behind moraines, lakes, and soils enriched by minerals. The oceans respond in turn. As ice grows on land, sea levels fall, exposing continental shelves and narrowing shallow seas. When ice melts, sea levels rise again, flooding low-lying regions and reshaping coastlines. Without pronounced tides, these changes feel especially smooth. Shorelines migrate gradually, allowing ecosystems time to adjust to new boundaries. Currents reorganize as sea levels shift. Gateways between ocean basins open and close over geological time, redirecting the slow flow of heat around the planet. The atmosphere follows. Colder oceans absorb more carbon dioxide. Warmer oceans release it more readily. These exchanges occur slowly, modulating global temperatures over thousands of years. Cloud cover adjusts. Winds respond. Rainfall patterns shift without abrupt transitions. Throughout these changes, Earth remains remarkably consistent in its behavior. There are no sharp breaks, no sudden resets. Each state grows naturally from the one before it. Day by day, night by night, the planet continues its turning. The absence of the moon means there is no bright marker in the sky to measure passing months. Time is sensed instead, through seasons, through the length of shadows at noon, through the slow migration of stars across the sky, over generations. This encourages a world shaped by long awareness, rather than short cycles. From the perspective of deep time, Earth without the moon is a planet that listens closely to itself. Its systems respond not to frequent external pulses, but to gradual internal balances. Energy flows in, circulates, and leaves again. Matter moves, settles, and moves once more. Nothing is wasted. Nothing is rushed. As Chapter 1 continues to unfold, the physical story of this world approaches its quiet completion. The stage is now fully prepared. Land, sea, air, and time have found their rhythm. And within these steady conditions, chemistry will soon give rise to something capable of persistence. The story of life waits just beyond the horizon. But for now, Earth turns alone beneath the stars, guided by sunlight, gravity, and the long patience of the universe. In this extended stillness, the surface of the planet grows increasingly familiar with its own patterns. Landscapes shaped by slow forces tend to endure. Plains broaden rather than fracture. Hills soften instead of collapsing. The absence of frequent tidal disturbance allows coastlines to evolve through rare events rather than constant motion. Storms still arrive, of course. Winds still gather strength over warm oceans and release it over land. Rain still falls in heavy sheets at times, carving channels and redistributing sediment. But between these moments, there is long calm. Beaches remain largely unchanged from one season to the next. Estuaries hold their forms. Mudflats dry and re-wet gently under the influence of weather rather than daily tides. These environments, shaped by steadiness, accumulate layers of history. Fine sediments settle slowly, building sequences that record variations in climate, chemistry, and water flow. Over time, these layers harden into rock, preserving faint impressions of a world moving at a measured pace. Far inland, soils deepen. Without rapid erosion driven by strong tidal currents, mineral-rich particles remain in place longer. Organic material accumulates. Microbial activity transforms raw sediment into fertile ground, capable of supporting increasingly complex chemistry. The land becomes not just a surface, but a reservoir. Water moves through this reservoir quietly. Rain infiltrates soil, feeds groundwater, and emerges again in springs and streams. These flows are steady, shaped by gravity and permeability, rather than by external rhythm. Aquifers form and persist for thousands of years, buffering the planet against short-term shifts in rainfall. In mountainous regions, snowmelt feeds rivers that run clear and cold. These rivers adjust their courses slowly, responding to uplift and erosion over long spans of time. Their paths become stable signatures on the land, revisited generation after generation. Above it all, the atmosphere continues its subtle circulation. High-altitude winds trace long arcs around the globe. Lower winds respond to terrain, forests, and temperature differences. Moisture rises, condenses, and falls again. Clouds form familiar patterns, returning to the same regions season after season. The planet's faster rotation maintains coherence in these systems, reinforcing broad bands of climate that persist across epochs. The result is a world where variability exists within limits. Change is constant, but rarely abrupt. This stability does not imply simplicity. Rather, it allows complexity to accumulate. Where conditions remain within workable ranges for long periods, interactions deepen, chemical gradients sharpen, feedbacks strengthen. Systems begin to influence one another in subtle ways. Energy from the sun enters the system each day, is transformed, stored briefly, and released again. Matter cycles through air, water, and rock, lingering longer in some places than others. These lingering moments matter. They create opportunities for persistence. As Chapter 1 approaches its natural conclusion, the physical portrait of Earth without the moon feels complete. Not static, but settled. Not quiet because nothing happens, but quiet because everything happens slowly enough to be absorbed. The planet has found its pace. In the absence of a nearby companion, Earth has learned to move by listening to itself. Its future stretches forward, measured not in cycles of light and shadow, but in the gradual unfolding of possibility. The next chapter will follow what emerges from this foundation, For now, the physical world rests, turning steadily, patiently, beneath a sky filled only with distant stars. As the ages continue to unfold, the influence of time itself becomes one of the most defining forces on this moonless earth. Time acts without preference. It smooths sharp edges, evens irregularities, and allows systems to settle into arrangements that can persist. On a planet governed by fewer short-term oscillations, time has space to do its work fully. Rock exposed at the surface slowly weathers. Temperature changes cause it to expand and contract. Water seeps into fractures, dissolving minerals and carrying them away. Wind abrades exposed faces grain by grain. Over centuries, solid stone becomes sediment. Over millennia, sediment becomes soil. This process unfolds everywhere. Across continents, broad regions of gently rolling terrain emerge, shaped not by sudden uplift or collapse, but by long exposure to the elements. Valleys widen rather than deepen. Slopes relax into shallow inclines. The land becomes readable, its forms reflecting extended stability rather than recent disruption. In these conditions, water pathways mature. Rivers no longer rush to adjust their courses. Instead, they meander deliberately, carving wide floodplains that absorb seasonal variations in rainfall. When water levels rise, rivers spill gently over their banks, depositing fine sediments that enrich the land. When levels fall, channels remain intact, ready to carry flow once more. Floods still occur, but they are integrated into the landscape rather than imposed upon it. Wetlands form along these mature river systems. Marshes, swamps, and shallow lakes spread across low-lying areas, filtering water and moderating flow. These environments act as buffers, slowing the movement of nutrients and energy through the system. In the absence of strong tidal forcing, coastal wetlands persist with remarkable consistency. Saltwater intrusion varies gradually with climate and sea level, allowing these regions to adapt without sudden collapse. Over time, this leads to a planet with extensive transitional zones, places where land and water, fresh and saline, solid and fluid, blend slowly rather than sharply. These zones play a quiet but essential role in regulating the planet. They absorb excess water during wet periods and release it slowly during dry ones. They trap sediments and organic material, building thick layers that store carbon and nutrients over long spans of time. The chemistry of Earth responds accordingly. Elements cycle through the system at measured rates. Carbon moves from atmosphere to ocean to sediment and back again. Nitrogen is fixed, transformed, and released through gradual processes tied to soil and water rather than rapid disturbance. Without the rhythmic stirring of strong tides, these cycles become smoother, less punctuated by short-term spikes. Concentrations change slowly, allowing feedbacks to stabilize. This chemical steadiness influences the planet's climate. Greenhouse gases rise and fall over extended intervals, guided by volcanic outgassing, weathering, and biological activity rather than abrupt shifts. Temperatures respond gradually, giving the planet time to adjust its circulation patterns and surface conditions. Ice sheets grow and recede without urgency. Forests migrate over generations. Deserts expand and contract at their margins, shaped by long-term precipitation trends. The planet remains active, but rarely surprised. At higher elevations, mountain climates persist as distinct environments. Snowfields feed streams year after year. Freeze and thaw continue their work on exposed rock, but slopes remain stable enough to support soils and vegetation over long periods. These upland regions serve as sources of fresh water and mineral nutrients, feeding lowlands and oceans alike. Across the oceans, the absence of strong tides allows large-scale circulation to dominate the movement of energy. Surface currents trace broad, continuous paths, driven by prevailing winds. Deep currents move slowly, guided by differences in temperature and salinity that evolve over centuries. Water masses retain their identities longer, carrying chemical signatures across vast distances. Upwelling still occurs where winds and currents align, bringing nutrients from depth to the surface. Productivity concentrates in these regions, waxing and waning with climate rather than daily motion. The seafloor remains a landscape of quiet contrast. Plains of sediment accumulate slowly beneath calm waters. Ridges and trenches mark the boundaries of tectonic plates, their forms changing only over millions of years. Hydrothermal systems continue to release heat and minerals, creating localized environments powered by Earth's interior rather than the sun. Above, the sky maintains its familiar structure. Daylight warms the surface. Darkness cools it. Clouds drift, storms form, and winds circulate, all governed by balances that shift gradually rather than abruptly. The lack of moonlight lends nights a uniform character. Darkness becomes a constant rather than a variable, shaping how energy leaves the surface and how temperature gradients develop. This constancy reinforces the planet's overall equilibrium. Nothing pushes the system too far, too fast. Instead, Earth continues to refine itself. Layer upon layer, interaction upon interaction, the physical world deepens its coherence. Processes that operate well together persist. Those that do not are slowly dampened. From the perspective of deep time, this moonless Earth is not diminished. It is simply different. Its rhythms are fewer but broader. Its changes are slower but more enduring. Its stability arises not from external guidance, but from internal balance. As Chapter 1 finally settles into silence, the physical foundations of this world stand complete. They are ready to support what comes next. In the calm left behind by the moon's absence, the conditions for persistence have quietly taken hold. The story will continue, but it will do so at the same unhurried pace, as all things on Earth eventually do. Chapter 2: Life and Time. Without the moon, life begins quietly, not as a sudden appearance, but as a gradual deepening of patterns already present in the physical world. On an Earth without the moon, the conditions that allow life to emerge are shaped by steadiness rather than rhythm, by persistence rather than repetition. In shallow waters warmed by sunlight, chemistry has time to explore itself. Molecules drift, collide, and bind. Energy flows through them in simple cycles, driven by light, heat, and the slow movement of water. There are no tides pulling these environments open and closed each day. Pools remain connected longer. Gradients persist. Reactions repeat under nearly identical conditions, allowing fragile arrangements to endure long enough to stabilize. Over immense spans of time, some of these arrangements begin to persist. They do not yet live, but they remain. And remaining is the first requirement of life. Across coastal margins and shallow seas, mineral-rich sediments provide surfaces where complex chemistry can unfold. Clays and metal-bearing compounds catalyze reactions, guiding molecules into repeating structures. In these calm environments, variation accumulates slowly rather than being washed away. Without strong tidal mixing, the boundary between water and sediment is less disturbed. Chemical layers form and remain in place. Differences in temperature, salinity, and composition persist long enough to matter. This persistence allows systems to refine themselves. Some molecular arrangements endure because they are stable. Others endure because they are flexible. Over time, both qualities prove useful. As these systems grow more complex, they begin to influence their surroundings. They alter local chemistry, changing concentrations of gases and dissolved minerals. Feedback emerges, subtle at first, but increasingly important. The absence of the moon does not slow this process. If anything, it allows it to proceed with fewer interruptions. Once self-sustaining reactions take hold, the distinction between environment and organism begins to blur. Boundaries form, not sharp walls, but soft separations that maintain internal conditions while allowing exchange. Early life on this Earth is shaped by continuity. Days are shorter than on the modern Earth, but nights are consistently dark. Sunlight arrives with reliable regularity, governed by rotation, rather than by lunar cycles. Energy input is predictable from one day to the next, even as seasons shift gradually over longer spans of time. This predictability favors systems that respond smoothly, rather than abruptly. As the first living processes spread, they do so across stable environments. Shallow seas, protected lagoons, and warm continental shelves become sites of gradual expansion. Life remains simple for long periods, refining its basic mechanisms rather than rapidly diversifying. Metabolism evolves as a quiet negotiation between chemistry and energy. Some organisms harness sunlight directly. Others rely on chemical gradients, drawing energy from reactions deep within sediments or near hydrothermal systems. Without dramatic tides to redistribute nutrients daily, life adapts to slower flows. Efficiency becomes valuable. Recycling becomes essential. Waste products accumulate locally, altering conditions and driving further adaptation. Oxygen, once a rare byproduct, begins to appear in small quantities near the surface. Its presence changes everything, slowly. As oxygen accumulates in the atmosphere and oceans, it opens new energetic pathways. Organisms capable of using it gain access to far more energy than those relying solely on anaerobic processes. This transition does not happen all at once. Oxygen levels rise and fall over long intervals, shaped by the balance between production and consumption. On a moonless Earth, these changes unfold with fewer oscillations. Atmospheric chemistry shifts gradually, allowing ecosystems time to respond. The oceans adjust. Iron reacts with oxygen and settles into sediments. New minerals form. The color and chemistry of seawater evolve. Life adapts not through sudden upheaval, but through extended refinement. As multicellular forms begin to emerge, they do so cautiously. Bodies grow larger only when conditions remain stable long enough to support them. Specialization appears where energy flow is reliable and environments persist. Without strong tides creating dynamic intertidal zones, early multicellular life develops primarily in subtidal and shallow marine environments. These regions offer consistency, light without exposure, nutrients without frequent displacement. Movement evolves slowly. Organisms explore their surroundings in measured ways, responding to gradients of light, chemicals, and temperature, rather than to rapidly changing physical conditions. Predation emerges, but it is restrained by the pace of the environment. Energy is valuable. Wasted motion is costly. As ecosystems grow more complex, interactions deepen. Food webs lengthen. Relationships stabilize. Symbiosis becomes a powerful strategy, allowing organisms to share resources and capabilities over long periods of time. On land, life waits. Without strong tidal zones to bridge sea and land, the transition out of the ocean is slower, yet it is not prevented. In sheltered coastal regions, microbial mats extend onto damp surfaces. Algae and bacteria tolerate brief exposure to air, gradually adapting to cycles of moisture and dryness, driven by weather rather than tides. Over time, these pioneers alter the land itself. They break down rock chemically. They trap dust. They contribute organic material to the surface, beginning the slow creation of soil. Plants emerge as extensions of this process, rooted in the land but dependent on water and sunlight. Their spread is gradual, guided by climate stability and the slow availability of nutrients. Forests, when they appear, are shaped by darkness. Nights without moonlight favor plants and animals that rely on internal rhythms and environmental cues other than light intensity. Growth responds to day length and seasonal shifts rather than to monthly cycles. Animals that follow will adapt to this world of steady darkness. Some rely on sound, others on scent or vibration. Vision evolves under starlight rather than moonlight, favoring sensitivity over acuity. Nocturnal life flourishes early, shaped by an environment where darkness is the norm rather than an exception. Time in this world is measured differently. Without the moon to mark weeks and months, biological rhythms align with days and seasons. Annual cycles become more significant. Long-term changes guide behavior across generations. Migration, reproduction, and dormancy follow patterns tied to climate and resource availability rather than lunar phases. This does not make life less ordered. It makes it ordered on longer scales. As life diversifies and spreads, Earth's surface becomes increasingly interconnected. Plants influence the atmosphere. Animals reshape landscapes. Microbes regulate chemistry at scales both vast and microscopic. Each influence feeds back into the others. Over deep time, these interactions give rise to a planet that feels alive, not because it changes quickly, but because it changes continuously. This moonless Earth supports a biosphere defined by patience. Life here is resilient because it grows within limits that rarely shift suddenly. It adapts by refining what already works, rather than by reinventing itself in response to frequent disturbance. As the chapter unfolds further, this living world will continue to deepen, branching into forests and seas, into night and day, into memory and behavior. For now, life has found its footing. It rests within time, shaped by darkness, steadiness, and the quiet inheritance of what came before. As life continues to spread across the oceans of this moonless Earth, marine ecosystems grow increasingly layered. In the upper waters, sunlight supports communities of microscopic organisms that drift with currents and winds. These simple forms capture energy, multiply slowly, and form the foundation of long, stable food chains. Because conditions change gradually, populations tend to fluctuate within narrow bounds rather than collapsing and rebounding. Below the surface, where light fades, life relies on chemical gradients and the slow rain of organic matter from above. Particles sink gently through the water column, feeding organisms adapted to scarcity and patience. Without strong tides to stir nutrients upward each day, productivity concentrates in regions where winds and currents bring deep water toward the surface. These zones become enduring centers of abundance, persisting for generations. Life learns to wait. Reproduction aligns with seasonal shifts in temperature and nutrient availability rather than with lunar cues. Spawning events are quieter, spread over longer intervals, reducing competition and waste. Predators emerge gradually, shaped by the need for efficiency rather than speed. Many rely on ambush, camouflage, or slow pursuit. Energy is conserved wherever possible. In the perpetual darkness of deeper waters, bioluminescence becomes a language rather than a spectacle. Soft glows communicate presence, attract mates, or confuse predators. These signals are subtle, tuned to an environment where even small changes matter. As life approaches the margins of land, the absence of tides continues to shape its path. Coastal ecosystems lack the regularly exposed intertidal zones familiar to a moon-bearing Earth. Instead, shallow waters remain submerged, protected from daily drying. Life here evolves to tolerate gradual changes in depth and temperature rather than frequent exposure to air. Transition to land occurs where moisture persists. Along riverbanks, lake margins, and sheltered coastlines, microbial communities extend onto damp surfaces. Over time, these pioneers modify their surroundings, trapping sediments and retaining water. Soils deepen slowly. Fungi-like organisms spread through these early soils, breaking down minerals and organic material, recycling nutrients with remarkable efficiency. Their networks grow dense and persistent, stabilized by the lack of frequent disturbance. Plants emerge within this framework. Early land plants are small and resilient, adapted to consistent darkness at night and predictable sunlight during the day. Their growth responds to seasonal temperature and day length rather than to changing night brightness. Forests, when they develop, form closed canopies that further stabilize the environment beneath them. Wind slows, moisture lingers, temperature extremes soften. These shaded worlds favor gradual change. Animals that follow plants onto land evolve senses attuned to subtle cues. Hearing becomes acute. Smell carries detailed information across still air. Vision adapts to low light, prioritizing sensitivity over sharpness. Nocturnal activity is not an exception here. It is a norm. Darkness is familiar rather than threatening. Behavior aligns with internal rhythms, synchronized to days and seasons rather than to lunar phases. Time, as experienced by living things, stretches. Without a bright monthly marker in the sky, cycles feel longer and less segmented. Biological clocks emphasize endurance. Growth, reproduction, and migration unfold over extended intervals. This encourages life histories built around longevity rather than rapid turnover. As generations pass, ecosystems deepen rather than diversify explosively. Relationships between species stabilize. Niches become well-defined. Competition gives way to balance. Extinction still occurs, but it arrives slowly, often driven by long-term climate trends rather than sudden disruption. Adaptation follows the same pace. Species shift ranges gradually. Traits refine incrementally. The biosphere evolves as a continuous process rather than a sequence of revolutions. From a distance, this living Earth appears calm. Forests spread and retreat over millennia. Oceans pulse gently with productivity. Deserts wax and wane at their margins. Nothing announces itself loudly. Yet life persists everywhere conditions allow. As Chapter 2 continues, this steady biosphere will give rise to memory, behavior, and eventually awareness. For now, life remains patient. It grows, adapts, and endures, moving forward at the same unhurried pace that has shaped the planet beneath it. As complexity increases, life on this moonless Earth begins to develop memory. Not memory in the sense of recollection, but persistence of pattern across time. Organisms retain information in their structures, in their behaviors, and in the ways they interact with their surroundings. Successful arrangements endure. Less effective ones fade. This accumulation of memory unfolds slowly, guided by environments that rarely change abruptly. In the oceans, larger bodies appear as energy flow becomes more reliable. Tissues specialize. Movement grows more coordinated. Nervous systems begin as simple networks, responding to gradients of light, chemistry, and pressure. Because darkness is constant at night, sensitivity becomes more valuable than speed. Many organisms learn to detect the faintest signals, vibrations in water, subtle chemical traces, minute changes in temperature. Communication evolves quietly. Color plays a smaller role under starlit skies. Instead, sound, motion, and gentle light emissions carry meaning. Bioluminescent signals grow refined, pulsing softly rather than flashing brightly, conserving energy while conveying information. Predator and prey relationships settle into long-term balances. Chases are rare. Encounters are deliberate. Survival depends on awareness and restraint rather than on bursts of activity. As life spreads across continents, terrestrial ecosystems follow similar principles. Plants extend root systems deep into stable soils, drawing water and nutrients from reliable reserves. Growth rates remain moderate. Longevity becomes a successful strategy. Trees, when they arise, live for centuries. Their presence alters local climates, moderating temperature and retaining moisture. Forests become reservoirs of stability, shaping wind patterns and rainfall at regional scales. Animals that inhabit these forests move carefully. Paths form through repeated use. Territories persist across generations. Knowledge is passed not only genetically, but behaviorally through learned routes, seasonal timing, and social structure. Without the moon's visible cycles, timekeeping relies on subtler cues. The angle of sunlight, the length of shadows, the timing of rains, the gradual shift of stars across the sky over decades. Biological rhythms align with these signals, reinforcing awareness of long-term change rather than short-term fluctuation. This encourages the development of cognition oriented toward anticipation rather than reaction. As brains grow more capable, they do so within environments that reward patience. Memory favors accuracy over speed. Learning emphasizes consistency. Awareness emerges as a gradual deepening of responsiveness to the world. On this earth, intelligence does not arise through sudden pressure. It arises through continuity. Social behavior evolves where cooperation improves efficiency. Groups share resources, defend territories, and care for offspring over extended periods. Communication grows nuanced, relying on posture, sound, and subtle gesture rather than dramatic display. Darkness shapes these interactions. Without moonlit nights, gatherings occur under stars or within sheltered environments. Fire, when it eventually appears, becomes a profound extension of daylight, offering warmth and focus rather than spectacle. As time moves forward, some species begin to alter their environments deliberately. They build structures, they modify waterways, they cultivate relationships with plants and other animals. These actions unfold slowly, guided by trial and continuity rather than by rapid innovation. When humans finally appear in this world, they do so within a long-established pattern of patience. Their ancestors evolved under skies without a monthly beacon. Nights were always dark. Stars were constant companions. Early humans measure time by seasons, migrations, and the return of familiar stars to the horizon. Stories form around constellations rather than around lunar phases. Calendars are anchored in solar motion and ecological cycles. Memory becomes central to survival. Knowledge is carried across generations through oral tradition, observation, and ritual tied to the land rather than to the sky's changing light. Agriculture, when it develops, favors stability over yield. Fields follow floodplains and rainfall patterns. Harvests align with seasonal certainty rather than with lunar timing. Societies grow slowly, shaped by environments that reward foresight and restraint. Expansion is measured. Change is deliberate. Technology advances in response to long-term needs rather than short-term scarcity. Across this moonless earth, civilization reflects the planet that shaped it. Steady, enduring, attuned to time not as a sequence of moments, but as a continuous flow. As Chapter 2 moves toward its closing reflections, life and time become inseparable. Biology no longer merely responds to the environment. It participates in shaping it. And through this participation, the planet itself grows increasingly aware of its own rhythms. Not through consciousness, but through connection. Life, in all its forms, becomes another way Earth listens to itself. As generations pass, this quiet listening deepens. Life on a moonless Earth grows increasingly skilled at inhabiting time rather than resisting it. Growth does not aim toward speed or dominance, but toward fit, an alignment between organism and environment that can be maintained across long spans. In forests, trees fall and return to soil without haste. Gaps open in the canopy, admitting light that encourages new growth. These cycles repeat slowly, creating mosaics of age and form that persist for centuries. Animals adapt to these steady landscapes by learning their contours intimately. Trails become memory written into the ground. Shelters are reused and refined. Seasonal movements follow reliable patterns shaped by rainfall, temperature, and plant growth, rather than by lunar brightness. In the oceans, similar persistence unfolds. Reefs, where they develop, grow as layered structures, built incrementally by countless generations. Without strong tidal stress, their forms emphasize stability over resistance. They expand outward and upward at measured rates, responding to sea level and temperature with patience. Schools of fish move in cohesive patterns, guided by currents and chemical cues. Their migrations align with seasonal productivity rather than monthly cycles. Timing is spread across intervals, reducing sudden strain on ecosystems. In the deep sea, where darkness is complete, life remains sparse but enduring. Organisms live long lives, conserving energy and reproducing infrequently. Their presence marks the success of persistence in an environment defined by constancy. As terrestrial life diversifies, large-bodied animals emerge, cautiously. Size evolves where stability permits it. Long lifespans become viable where resources are reliable. Social structures grow around shared memory. Knowledge of roots, water sources, and shelter passed down through observation and imitation. Communication in these societies is quiet and continuous. Signals are subtle. Sounds are measured. Silence itself becomes informative. Without a moon to brighten the night, gatherings cluster around warmth and familiarity. Firelight, when present, creates small islands of illumination within vast darkness. Beyond these circles, the stars remain unchanged. This constancy shapes early human thought. The night sky does not fluctuate dramatically from week to week. Instead, it changes slowly over years, as constellations shift with the seasons, and the planet's orbit carries familiar stars into new positions. Time is understood as flow rather than division. Stories emphasize continuity, origins, migrations, cycles of return. Meaning is drawn from landscapes and seasons, from rivers and mountains that endure across generations. Calendars, where they arise, are solar and ecological. They mark planting and harvest, migration and dormancy. Months, if they exist at all, are defined by weather patterns or biological events, rather than by phases of light. This fosters cultures attuned to anticipation. Decisions are made with long horizons in mind. Knowledge is valued not for novelty, but for reliability. Change is approached carefully, tested against experience, rather than embraced for its own sake. As civilizations expand, they do so in dialogue with their surroundings. Cities grow near water sources and fertile land. Architecture reflects the need for thermal stability. sheltering inhabitants from sharper day-night contrasts. Materials are chosen for longevity. Structures are repaired and adapted rather than replaced. Light, when used, is purposeful. Night remains mostly dark. Illumination is localized, preserving the stars and the natural rhythms of living things. This darkness nurtures reflection. Without a moon to dominate the sky, the Milky Way becomes a constant presence, a reminder of scale and distance. Awareness of the cosmos develops not through spectacle, but through familiarity. Philosophies arise that emphasize balance, patience, and continuity. Time is understood not as something to be measured precisely, but as something to be inhabited. As this chapter continues to unfold, life and time intertwine more fully. Evolution does not rush toward endpoints. Cultures do not chase constant acceleration. Instead, the living world settles into a long conversation with itself. A conversation carried by soil and water, by memory and behavior, by darkness and light. On this earth without the moon, life becomes an expression of steadiness. It persists not by resisting change, but by moving with it, slowly, attentively, and without urgency. As centuries turn into millennia, the relationship between life and environment on this moonless earth grows increasingly intimate. Each generation inherits not only genetic information, but landscapes already shaped by those who came before. Forests carry the memory of past climates in the width of their rings. River valleys reflect ancient paths of water etched slowly into stone. Soils preserve layers of organic matter laid down over countless quiet seasons. Life learns to read these records. Animals recognize patterns in the land that extend beyond a single lifetime. Migration routes align with long-standing corridors of vegetation and water. Breeding grounds return generation after generation, chosen not for convenience, but for reliability. In the absence of a lunar cycle to punctuate time, continuity becomes the dominant organizing principle. Behavior favors strategies that can be repeated safely across years. Risk is minimized. Exploration occurs cautiously, guided by accumulated knowledge rather than impulse. This tendency shapes the evolution of social bonds. Communities form around shared memory. Elders carry importance not through authority, but through experience. Knowledge of rare events, droughts, floods, shifts in climate, is preserved through storytelling and practice. These stories are not dramatic, they are instructional. They teach where to find water when rivers run low, when to plant before seasonal rains, how to recognize subtle changes in wind or sky that signal longer-term shifts. Language itself evolves to carry nuance rather than urgency. Words emphasize duration, gradual change, and continuity. Concepts of time stretch outward, encompassing generations rather than moments. As agriculture deepens, it does so gently. Fields are rotated slowly. Land is allowed to rest. Crops are selected for resilience and compatibility with local conditions rather than for maximum yield. Farming becomes a conversation with the land rather than an imposition upon it. Without lunar calendars, planting schedules rely on temperature trends, soil moisture, and the behavior of plants and animals. Observations accumulate over centuries, refining practices that align closely with regional climates. Settlements grow organically. Villages follow terrain. Paths curve around natural features rather than cutting through them. Architecture reflects an understanding of seasonal sunlight and shade, capturing warmth during the day and releasing it slowly at night. Buildings endure because they are adapted, not because they are monumental. Trade emerges along stable routes, guided by geography and long-standing relationships. Exchange favors materials and knowledge that endure. Seeds, tools, techniques. Conflict, when it arises, is shaped by the same constraints. Without rapid expansion or sudden scarcity, driven by short-term cycles, disputes tend to be localized and resolved through negotiation. Memory of past outcomes informs restraint. Over long spans of time, societies on this earth develop a shared orientation toward the future. Planning horizons extend outward. Decisions are weighed against their impact on land, water, and generations yet to come. This does not eliminate change, it moderates it. As climates shift slowly, human cultures adapt by migrating gradually, altering practices and exchanging knowledge across regions. Large-scale collapse becomes less common than gradual transformation. Throughout these changes, the night sky remains constant. Stars continue their slow drift across centuries, providing a backdrop against which human history unfolds. Without the moon to dominate attention, the cosmos is perceived as a steady presence rather than a fluctuating spectacle. Astronomy develops as an observational tradition grounded in patience. Movements of planets and stars are tracked across generations, revealing patterns only visible through long-term study. This reinforces a worldview that values accumulation of knowledge over time. Science emerges not as a rush toward discovery, but as a careful refinement of understanding. Observations are recorded, patterns are compared, explanations are tested against long histories rather than short experiments. Technology follows a similar path. Tools are improved incrementally. Innovations are adopted slowly, assessed for their compatibility with existing systems. Sudden transformation is viewed with caution. Energy use reflects this restraint. Sources are chosen for reliability and sustainability rather than immediacy. Firewood is managed carefully. Water power and wind are harnessed where geography allows, integrated into landscapes rather than imposed upon them. As centuries pass, civilizations rise and fade without sharp breaks. Ruins are not abandoned abruptly, but repurposed. Stones are reused. Knowledge is preserved through continuity of practice. History feels less like a sequence of eras and more like a flowing current. As Chapter 2 continues its descent toward closure, life on this moonless Earth appears deeply embedded within time, not racing toward an endpoint, not resisting change, but moving steadily, guided by memory, patience, and attention. In this world, the absence of the moon has not diminished life. It has taught it how to endure. As the far future unfolds, the influence of this endurance becomes even more apparent. Civilizations on a moonless Earth do not vanish abruptly. They thin, transform, and drift into new forms, leaving behind layered traces rather than sharp endings. Cities slowly return portions of themselves to soil and vegetation. Roads soften into paths. Structures weather and are reused, their materials folded back into new designs. The boundary between the human world and the natural world remains porous. Over long spans of time, technology and ecology intertwine. Human activity shapes landscapes, but those landscapes continue to shape human behavior in return. Settlements adapt to shifting coastlines and climates rather than attempting to resist them. When populations move, they do so gradually, following water, soil, and climate, rather than abandoning places suddenly. Memory guides these migrations, preserving knowledge of where stability can be found. The absence of a lunar cycle continues to influence perception. Night remains consistently dark. Artificial light is used sparingly, valued for its function rather than its presence. The stars remain visible across generations, reinforcing awareness of scale and continuity. Children grow up knowing the sky not as a changing display, but as a familiar reference, steady, vast, and indifferent to short-lived concerns. This perspective shapes values. Ambition tends to be measured against longevity. Achievements are judged by how well they integrate into existing systems, rather than by how dramatically they alter them. Legacy is understood as contribution to continuity. As knowledge accumulates, it does so through careful preservation. Libraries, archives, and oral traditions emphasize redundancy and resilience. Information is distributed rather than centralized, ensuring survival across disruption. Scientific understanding deepens through patient observation. Long-term records of climate, ecology, and astronomy allow subtle trends to be recognized centuries before they become disruptive. This foresight enables adaptation without crisis. As planetary conditions evolve over millions of years, life continues to adjust. Continents drift, mountain ranges erode, new coastlines emerge, species shift ranges or slowly transform. Human cultures follow these changes not by forcing stability, but by maintaining alignment with the land. In this way, intelligence becomes ecological. It serves not only survival, but balance. Far beyond the horizon of recorded history, the biosphere remains active. Forests rise and fall. Oceans circulate heat. Ice advances and retreats. Life remains present wherever conditions allow. Even if human civilizations eventually fade, they do so gently, leaving behind altered soils, redistributed species, and traces of knowledge embedded in the landscape. The planet does not remember individuals. It remembers patterns, and those patterns persist as long as energy flows through the system. As this chapter draws toward its close, life and time appear inseparable from the Earth itself. The absence of the moon has not deprived this world of rhythm. It has given it fewer rhythms, stretched across greater spans. Days and seasons remain, but beyond them lies continuity, a sense of belonging to processes too slow to notice, yet too persistent to ignore. In the end, Earth without the moon is not a lesser world. It is a quieter one, a planet that moves forward without emphasis, without punctuation, without haste. It turns beneath the stars as it always has, carrying life not toward an ending, but through time itself. Beyond even the far future of human memory, Earth continues its quiet work. Life persists not as a single story, but as countless overlapping processes unfolding at different speeds. Some changes happen within lifetimes. Others require thousands or millions of years. On this moonless Earth, these layers of time coexist without conflict. As continents continue to drift, oceans slowly rearrange themselves. New currents form as gateways open and close. Heat is redistributed in patterns that evolve gradually, allowing ecosystems to migrate rather than fracture. Forests move poleward or retreat toward the equator as climates shift. Grasslands expand into regions once covered by trees. Deserts soften at their margins, then sharpen again under changing precipitation. Life follows. Species adapt not by sudden leaps, but by subtle refinements. Limbs lengthen or shorten. Metabolisms adjust to new temperature ranges. Sensory systems tune themselves to prevailing conditions of light, sound, and chemistry. On a world without lunar cycles, biological clocks emphasize endurance over immediacy. Traits that support long-term survival persist. Those that demand constant recalibration fade. Extinction remains part of the story, but it unfolds quietly. Most losses occur gradually, as habitats shift beyond what certain species can tolerate. Others adapt and continue, carrying forward modified versions of earlier forms. In this way, the biosphere remains fluid without becoming unstable. Even mass changes in climate are absorbed over long intervals. Ice ages arrive slowly and depart the same way. Sea levels rise and fall over tens of thousands of years, giving coastlines time to reshape themselves and life time to respond. The darkness of night continues to shape behavior. Without moonlight, nocturnal life remains dominant across many environments. Predators and prey rely on sound, scent, and subtle motion. Vision remains sensitive rather than sharp, attuned to starlight and bioluminescence. The stars themselves remain fixed companions, though individual constellations shift over deep time due to Earth's motion through space. These changes are imperceptible within a lifetime. The sky offers continuity even as the ground beneath it slowly transforms. This constancy reinforces a sense of belonging for any intelligent life that persists. Awareness, when it arises, remains grounded in relationship rather than control. Technologies that endure are those that harmonize with existing systems. Energy flows are managed rather than exploited. Materials are reused and repurposed, folded back into the landscape when no longer needed. Civilizations, if present, leave behind more gardens than ruins. Stone structures weather into terraces that support plants. Channels dug for water become wetlands. Altered soils continue to nourish life long after their makers are gone. The planet absorbs these traces without resistance. From a geological perspective, they are brief additions, thin layers among countless others. Yet even these layers contribute to the ongoing dialogue between life and Earth. As time extends further still, the sun itself begins its slow transformation. Its output changes gradually, altering the balance of energy reaching the planet. On a moonless Earth accustomed to gradual change, life responds by shifting ranges, adjusting cycles, and seeking new equilibria. Some environments become less hospitable, others emerge in their place. The biosphere contracts and expands, but it does so smoothly, guided by the same principles of endurance that shaped its beginning. Eventually, conditions may narrow beyond what complex life can tolerate. But even then, the transition is not abrupt. Microbial life persists longest, inhabiting protected niches where water, chemistry, and heat remain available. These simple forms continue cycling matter and energy quietly, long after larger organisms have faded. Earth does not become empty, it becomes simpler, and simplicity, too, is a stable state. As this long journey continues, the absence of the moon remains a defining influence, not as a loss, but as a shaping condition. Without frequent external punctuation, the planet has learned to move by listening inward. Change arrives as a slow turning, rather than a sudden break. Life adapts by remaining flexible, patient, and responsive. Time unfolds without emphasis, and Earth, still turning beneath a dark, familiar sky, carries this quiet continuity forward, holding its story not in moments, but in the long, unbroken flow of becoming.